In this video, I'll review Module 15, which is static routing. So we will look at static routes, how static routes work in comparison to dynamic routes. Also, how to configure IP static routes, default static routes, floating static routes, and we will look at how to configure both of those in both IP version 4 and version 6. So there are various types of static routes. If you remember from Module 14, we looked at how to configure a router and then the differences between dynamic and static routes. With dynamic routes, we learn that the router determines the path for data. However, in static routes, someone else, usually the network administrator, would configure that into the router. So that would appear in the routing table for the router. When you issue the show IP route command, you would see the routes that the router has learned. Okay? That could be dynamic or static. Static routes can be configured for both IP version 4 and version 6. There are standard static routes, so we'll look at that first. We'll look at default static routes, floating static routes, and summary static routes. Typically, when you configure a static route, the syntax would be IP route, done at your privilege mode prompt, the IP route, the destination network, its mask, and then either the exit interface or the next hop address. The difference between the ways that the address is specified is that the next hop route would be the route that the data needs to take as it goes to the next device. That would be your next hop. So if you're in R1, you're configuring a static route to reach a network beyond R2, then the data would have to travel to R2. So the next hop address would be the incoming interface on R2. Now, directly connected static route, if you're configuring for the connected interface, then you use the exit interface on R1, for example. If it's a fully specified static route, you would list both the exit interface on that router plus the next hop address of the next device. So it would be if R1 and R2, for example, you're configuring R1, you would list the exit interface and then the incoming interface or ingress interface on R2. Again, this is your syntax. So config T, then IP route, the destination network, its subnet mask, and then either the next hop address or the exit interface. If configuring IPv6, you would use the same syntax, but remember that you don't have a subnet mask when you're configuring an IPv6 address, so you would use the / notation or prefix length. So instead of IP route, it would be IPv6 route, the destination network with a / notation, and then either the exit interface or the next hop address. It is possible to configure static routes for both IP version 4 and IP version 6. You can configure IP addresses for both IP version 4 and IP version 6. You can configure static routes for both, so you can use those dual. You can do that because IP version 4 talks to other IP version 4 addresses. Same thing with version 6. So version 6 is going to communicate with other version 6 devices. They don't cross over, so you can put both on the devices. Now, if you're actually looking at a configuration, so IP version 4 routing table, if you see the C's and the L's, the C's indicate the network that was used. So I'm going to go back up here. So for R1, R2, and R3, if you're doing your basic configuration, so no static routes have been configured. We see that listed here. No static routes are configured for either version 4 or version 6. So what's been done is in R1, they've done the basic device configuration where they configured G000 with the correct address, which would be the 172.16.3.1. This interface has been configured. For R2, the S010 has been configured, G00 and S011. For R3, these two interfaces have been configured. You would see those indicated with a C and L. If you're looking at R1, the interface address is actually 172.16.2.1. It's connected to network 2.0. So if you were looking at that, that would be this particular interface here. It's 2.1. That would be the L. The C would be the network it's connected to. So because you have an interface on this network, it does make that as one of your connected networks. Okay, and that's how it would work throughout the entire network. So if you were to look at R2, you would see the same thing. You would see lots of C's and lots of L's. These are just the interfaces that are configured during your basic configuration. Same thing with R3. In this case, R1 can ping R2, but R1 cannot ping R3. Why is that the case? Well, R1 can ping R2, it knows about this network because it has a device connected to it, but it doesn't know about the far-reaching networks. Okay. So I'm going to go back to R1's routing table. So R1 knows about the 2.0 network and the 3.0 network. Okay, so 172.16.2.0 and 172.16.3.0. It doesn't know about this network, this one, or this one. Okay, so there's 1, 2, 3, 4, 5 networks. Yet, if we look at the C's, we only see 2 networks. So going back to Module 14 in this curriculum, which was the last section on configuring routers, routing concepts, I believe. Now, just because one router knows about a path or a particular set of networks, it doesn't mean that other routers know about it. Okay, so that's one of the rules, and you have to go through and look at the routing table for every single router. Okay, so just because one router knows about the path doesn't mean another one does. Just because a router knows how to reach a destination doesn't mean it knows how to return. Also, if you have 5 networks in your topology, you should see all 5 networks listed. If you do not, then that device will not know how to reach all the devices within the topology. Okay. So again, think about a router's GPS. So if you're trying to get from point A to point B, and some of the routes are not listed, you're going to have some missing links. You're not going to be able to actually get there. You might travel a lot longer direction. You're just not going to know, probably not know how to find the address that you're looking for. So this is the same way with a router. Okay, each router needs to know about all of the networks within the topology. So again, if there are 5 networks in the topology, then R1 needs to have knowledge of 5 networks. R2 does, and so does R3. Right now they do not, but that would change after entering in static routes. Same way with IPv6. So we have the 2 networks that we know about. For R1, same with R2, we know about 3 networks, and then the same thing with R3. So R1 can ping R2 because it knows about that one, but it doesn't know how to reach this far destination, just like with version 6. So that really doesn't change between version 4 and version 6. in the way they need to know the knowledge of the network and how they reach those networks and how they build their routing tables. That all stays the same. So if you are looking at the output for R1, R1 knows about this network 172.16.3.0 and 172.16.2.0. So they're configuring R1 with static routes to the 3 remote networks, which would mean it would be the 172.16.1.0, 192.168.1.0, and 192.168.2.0. So this is the correct syntax. You would type IP route, again at your privilege mode prompt. So IP route 172.16.1.0, that would be the first one here. Its mask is 255.255.255.0. You can see that because of the /24 listed. Now we're using a next hop address. So if data is leaving R1, to reach this network, it has to go to this interface on R2 in order to reach it. That's the next logical interface that it would need to go to. So with 192.168.1.0 being over here, data would also have to leave R1 and travel to R2. So that would also be the next hop address. And same with 192.168.2.0, because of the topology, that data would also have to travel from R1 to R2. And again, that would be the next hop address. If you put in all 3 of those, then you will see entries that look like this. They will have an S. An S indicates a static route. And you will see those entries appear. So just for review, when you're looking at a routing table, you would see how you learned about the route, which would be the S. The network, this is the administrative distance. The administrative distance is the trustworthiness of a route. The lower the number, the more trustworthy it is. So if it's on a directly connected interface, such as this one down here, that's on that device, it says directly connected. It's actually not listed, but the administrative distance for a directly connected device would be 0. You can't get more trustworthy than on the device itself. Static routes are next in terms of how trustworthy they are. The administrative distance is 1, and it's 0 hops away. That's the metric. So it's just the next device, so it doesn't have to travel any further. If you had to pass through 3 routers to get there, then the metric would be 3. This is the next hop address. So you get here by going here. That's the same way it would read for the other 2 static entries. With IP version 6, before you can type in the addresses or the static routes, you would have to type in the command IPv6 unicast routing. Once you type that in, you can type in the static routes. And again, the syntax is IPv6 route instead of IP route. The destination network, you're using the / notation because you're using IP version 6, and then the next hop address. And when you do that, you'll see the route appear with the S, just like you did in IP version 4. Okay, you'll see the administrative distance, you'll see the metric, and then you will see the next hop. Another option is to use the exit interface instead of the next hop address. If you were to do that, if you're looking at R1 and trying to type in the static route entry for 1.0, the 172.16.1.0, you would still use the destination network, the mask, but you would use the exiting interface on that particular device. So S010. It's not the address, notice, it is the actual interface. Now, what are the advantages and disadvantages to doing that? Well, there's a couple of advantages and disadvantages. Note here in this area, they tell you the next hop address is generally recommended. and only recommend using directly connected static routes for point-to-point serial interfaces. So what you'll see is the next hop address. So why would you use a directly connected interface? Well, here's the advantage to using a directly connected interface. It prevents something called recursive lookup. So if you remember from the previous part of this curriculum, or maybe CCNA 1, that the routing table is going to try to match the longest match in each one of these routing table entries. So it's going to go line by line using the destination address, and then choose each one of these networks, take everything in binary, and try to find the longest match, to find the best match for that particular destination. When it does that, so it would determine then, well, what interface do I need to use in order to get to the 2.0 network? So it would need to match up everything in the routing table, then determine what exit interface to use in order to reach that. If you use the directly connected interface, it prevents the router from having to do that. So it doesn't have to go through all that. It just says, go this way. So it prevents what we call the recursive lookup of having to figure all that out. So I'm still not quite sure on why Cisco would always recommend using that next hop address. It seems like it would be more efficient to use exit interface, but that is what is taught in the Cisco Academy curriculum, and it's stated that that's preferred, so we follow those guidelines. But as a side note, I personally kind of wonder why it wouldn't just be more useful to use the exit interface. Okay, so IPv6 directly connected static routes are configured the same way as version 4. So IPv6 route, the destination network, and then again the interface, exit interface. If you wanted to specify everything, you would use the fully specified static route, which would indicate both. Here's what it would look like. IP route 172.16.1.0 with the mask and then the exit interface. And you can abbreviate all this. You don't have to write it all out. So you could do the G001. Okay, so the exit interface and then the next hop. And you can do that with both version 4 and version 6. To verify a static route, you can issue the command show IP route static, show IP route network, show run, and you can use the pipeline if you want for section and just showing you IP route. It is not wrong if you just wanted to type show run. This is for IP version 4. If you wanted to replace the IP with IPv6, you could check your IPv6 routes. So here's examples of a show command. So show IP route static. So you're looking just at the static entries only. If you want to look at a specific route, you could do that. Show IP route, so just for 192.168.2.1. You could display the IPv4 static route information only here. Do the same thing with version 6. Looking at IPv6 static routes. If you're looking at a specific network, you can list that like you did with version 4. And then you could use the pipeline here with your show run command to look specifically for IPv6 route information. So this is the first part of Module 15 on your different types of static routes and looking at the routing table. Hopefully this will give you a little bit better understanding of how to configure a static route and how to find that information and view it in your routing table.